Hi Chemistry. Today we're going to continue talking about Le Chatelier's principle, do a couple of examples, and then build to what happens with temperature changes. Okay, so I want you to just remember that the Le Chatelier's principle states that an equilibrium system shifts to the side that will oppose the initial change to the system. Okay, so I've got a simple equilibrium system there, formation of water, and we're just going to do a nice example here. We're going to determine the shift that will occur if hydrogen is added. All right. So I like to draw little arrows. If hydrogen's added, the system responds to get rid of some of that extra hydrogen. Okay. The only way it can do that is by reacting it with oxygen. So the oxygen's also going to go down, and you're going to get more water. Okay. So when more reactants produce products, that's called a shift right, or shift toward the product, because more products are being produced. Okay. What happens if we remove oxygen? Okay, so our initial change here is we're going to take some of the oxygen out of the system. Well, the system notices that and wants to replace some of it. The only way it can replace some of it is by having the reverse reaction occur. Water is going to have to go back into hydrogen and oxygen. In order to do that, its concentration will go down. If oxygen's brought up, hydrogen's got to be brought up too. Okay, that's a shift toward the reactants. It's a shift left. Okay, so I could also ask you a question. What will happen to the hydrogen concentration if oxygen is removed? Okay, we didn't touch the hydrogen in part B. We just took out some oxygen from the system. Well, in response, there's going to be more hydrogen available. The concentration of hydrogen will increase because the system responds to the change by producing more oxygen. It can't produce just oxygen. If it's going to produce more oxygen, it also has to produce more hydrogen. All right, let's move on a little bit. Okay, so something I want to get out of the way, it's really similar to Kc. Le Chatelier's principle applies to concentration changes. So if you add or subtract entities that are solid or liquid form, there's no change to the equilibrium. So I've got a nice example here, silver nitrate with sodium chloride, and you get that silver chloride precipitate. Okay, if I add silver ions, the concentration of silver ions will increase. There'll be more collisions, more reactions with chloride. You'll get more silver chloride. Okay, so adding silver ions, it's aqueous, does increase concentration. Equilibrium will shift. Equilibrium will respond to that. But if you add silver chloride, just drop some more powder into this beaker, say, nothing's going to happen, because adding more silver chloride doesn't affect the concentration of silver chloride. And I tried to convince you of that principle with almonds in a previous video. All right. Now let's talk about temperature. Temperature changes affect equilibrium, also Kc. Keep that in the back of your head. That'll be a question at some time. The direction that the equilibrium shifts depends on whether the forward reaction is exothermic or endothermic. It's pretty simple. If you understand what's going on with Le Chatelier, this is going to be no problem. Okay, so I've got this formation of water again. I got the enthalpy change. That negative sign means that this is exothermic. That's very important. What I'm going to suggest you do is add an energy term to your equilibrium system. This is exothermic, so I'm going to add energy to the right. Then you just treat it like any old reactant or product. So let's determine the shift in equilibrium that occurs when temperature is decreased. You can probably tell I got some windows open today. Beautiful spring day. I've also got an Amazon Echo that keeps trying to connect to Bluetooth. It's driving me crazy. Maybe you've heard that too. Okay, so if the temperature is decreased, we've removed energy from the system. Okay, and the system responds to try to replace some of that. The only way it's going to be able to replace energy is by shifting to the right, producing more water at the expense of hydrogen or oxygen. Okay, so that's going to be a shift right. And again, it's identical to if we removed water from the system. Okay, equilibrium will shift to replace some of it. So with temperature, my recommendation is add an energy term to whatever side is appropriate. add it to the right because this was exothermic. If it was endothermic, we'd add it to the left. And then you just treat it like any reactant or product.